Can someone confirm that they got some notification that it was recording or something?
Didn't get a notification, but it does show it's recording.
Okay, cool. Thank you very much. The other thing before we get started, I'm thinking, so 6 to 9 is a very rough estimate. This is the first time I'm doing this, so we'll see how long it actually takes. I hope I won't keep you after 9, but maybe if we work fast, we can get done sooner than that. The thing I was thinking is that maybe we could take a 5 or 10 minute bathroom break at 7 and 8. If folks want to just, I don't know if someone feels, folks should just remind me when it's 7 o'clock, because I'll probably just be babbling, and then and so if you feel, I will not be at all offended if you say, CJ, you told us we could go to the bathroom and you haven't, so just flag me and let me know. But hopefully I'll remember. Okay, it looks like a few people are having login issues. Can't minimize Zoom. I'm recording. Just a couple more minutes and we are going to get started. I just want to let people trickle in. It seems like some folks are having issues with the login. I'm getting a few emails. All right, I think we're gonna get started. If any of you know folks who are having trouble getting on, it may require a Zoom update. If not, the meeting ID should be, I'm just gonna struggle to maintain emails while people email me, but if anyone knows folks who are having trouble, I will put the ID in the chat, and that should, you can give that to friends who are having trouble. So thanks for joining, everybody. I'm really excited to talk to you about Stata. It's a thing I enjoy doing. It's a weird thing that I enjoy doing, but it's very good, very useful statistical tool. And so my game plan is to try to just take you from 0 to slightly dangerous, so there's like a very weird thing to statistical analysis, which is like it's way easier to learn the coding language than it is to learn the statistical theory. And so I'm going to give you tools to do all sorts of dangerous things. Do it at your own risk. Be careful, make sure you know the things you're doing, but mostly for the most part, what we're going to be doing is just sort of data manipulation and data management stuff. We're not going to lean too hard into statistical tests or anything really challenging in terms of theory or practice. But just keep in mind that just because you can do the coding doesn't mean you can always be super confident in bold claims about the underlying data. So, but we're going to try to give you as many tools as we can in a short period of time. As a result, one of the things I'm going to do is stop in a few places and ask you to try things out really quickly. So you'll want to have Stata up and ready to go. And I'm also going to have you importing data several times. And so I'm going to try to go as slow as I can to make sure that you guys have a chance to keep up. One of the things with Stata is that as you get better at it, you forget what it's like to be a newbie, and so it's hard to always feel like as someone who talks fast in the first place, it's also there's a strong tendency to just move too fast. So just slow me down if I'm going too fast, and then. I think that's all the table setting I want to do. I'm going to just try to share my screen again and see if I can do this right. Okay, so that's part of my email, but now you should be seeing this data tutorial. Let me see if I can bring up the chat at the same time. I don't think I can. But if you need me, flag me down in some way. Hopefully the chat will alert me. Okay, so what is Stata? So, like the fanciest way to talk about what Stata is that it's a command line statistical package. What I want you to do is think. Well, one thing that was helpful for me when I was first learning about Stata was to distinguish between the way I'm used to working with data, or I was used to working with data, which was in spreadsheets, and what Stata does, right? So Excel, to make it so user friendly or to make it as user friendly as possible, like the program is the spreadsheet, right? When you open Excel, when you open an Excel file, you're looking at a spreadsheet. And so it's a little hard to distinguish the program from the spreadsheet itself. That's not true for Stata. Stata interprets spreadsheets, it opens spreadsheets, it uses them as sort of the input to, it's like the object that you're acting on when you make commands. And so it's kind of organized differently. And that can be a little disorienting at first, but the basic thing you need to know is that the object that it's working on is underneath the hood, in the part that you don't often see, unless you go out of your way to, is the same as a spreadsheet that you would see in Excel, right? It has rows and columns, and the rows generally represent some form of observation, right? You've observed data on something, right? Maybe it's students in a school, or maybe it's patients with COVID or something like that. You have some list of people and you have some information about them. And so each row is a different person or a different classroom or a different dog or whatever it is you're recording data on. And each row or each column has a different characteristic about them, right? So it might be the teacher, the average height of the students, or sorry, the height of the students, the years of growth among tested students, right? There's lots of different things that you could imagine you want to record, and you might want to record multiple things for the same person. So we might have a row of people where we want to know their height, their age, their weight, their shoe size, right? All those sorts of things. And so each row has one person. Each column has a different one of those characteristics, and those characteristics generally vary across the population that you're collecting information on. And Stata is a way of taking that. I mean, I think like a lot of people talk about data these days and very excited. Everything's data, data, data. And it sounds very cool. But I think, if we just talked about it as what it is, it would sound much less cool. It's just organized information, right? We want to just keep organized information on things. And Stata is another way of doing that. So super easy, basic thing, but I just want to distinguish between the object we're working with and the program that's operating on that object. The other thing that's going to look different to you from what you might be used to, and say, I should probably get rid of this so it's not in the way. So the other thing you might not be used to is that we're going to be using commands rather than sort of the graphical user interface that you're used to, right? So normally you tell a program what to do by pressing buttons, clicking, occasionally typing some things in, but mostly you're using your mouse and you're using the graphical user interface. Maybe it's menus, maybe it's a button, right? That tells the program what to do. In the command line tools, what distinguishes something like Excel from something like Stata or R or Python or whatever other command line tool you might use is that you use commands. You type words and they cause the program to do things. And so the structure so I just want to recognize that may be unfamiliar to folks, and I don't want to leave anything, I don't want to assume any knowledge here. So the basic structure of command line tools in Stata in particular is there's basically the command, and sometimes it's a variable name or sometimes it's some other form of object. But basically, the way I think about it is there's the thing you want, there's what you want to do, and there's the thing you want to do it to, right? And that's the basic structure of Stata commands. It's that you're going to write a word, and just like in natural English language or any language, or I assume any language, there's commands, right? If I say, go pet the dog, right? Go pet the dog is going to go, or maybe go pet, whatever, is going to tell you what to do. And there's some object on which you're going to be acting, that's the dog, or maybe you, or whatever. So if I'm telling you what to do, we have a set of words in the English language that are commands, right? Or we have verbs that are associated with specific actions, and we can tell people to do things with those actions. Stata also has its own language where it's got a bunch of words that stand for specific actions. They're statistical actions, but nevertheless, it's a specific action that you want the program to do, and that's I just want to be clear that that's not something you're unfamiliar with. You just have to learn the language, right? And language learning is hard. If you've ever done it, it's very challenging, and it's going to be challenging here too, but it's not more complicated than learning the verbs, right? Learning what commands do what, and that today is just going to be a big overview of learning the verbs for the most part. Okay, so that's enough table setting. Why don't we open up Stata? So just, I'm gonna bring Stata up here. Yours might look a little bit different than mine. It may also look different if you're working on a Mac. I'm just gonna try to I'm gonna stop sharing real quick so that I can try to see what's going on. I wanna see the chat. Can folks just, a few folks just give me a sense of if you've got Stata open, if you feel like you're, yeah, actually the thumbs ups are really, really good. That's a really quick way for me to see it if you know how to use those reactions. If you feel like you've got Stata open, I'm just going to wait for sort of a critical mass of folks. Okay, seems like folks are, for the most part, being able to do it. That's wonderful to hear. Okay, so let me, I cannot minimize. I keep wanting to minimize. Okay, so I'm going to share my screen again, and I'm going to show you Stata. Your Mac, if you're on Mac interface, it might look a little bit different. If you have a different version of Stata, it might look a little bit different, but the basic thing, the basic interface should look the same. So you've got this command window where you can put in different commands, right? So a very simple command is display, and I can say display like, just some words, and then I enclose them in quotes, and then Stata will return back some things. Now, don't worry if your stuff doesn't have this. I just have weird settings on my Stata that tell me how long a command takes to execute, because sometimes I'm executing bigger data stuff and I need to know how long it takes so I can do things faster. But so don't worry if you don't have that. And so a few things happen here. So I put the command into the command window. I get the results in the results window, right? Here's the command displayed. Here's the results from it, right? It displayed this this set of words, and then I also see here that this is sort of called the review window. This is the history of the commands that I've executed, and so here's the one I just executed. If I click it once, it pops back into the command window, and I can run it again if I want to. And now I see it's here again, right? So you can always go back and find you can find old windows, or sorry, find old commands, which can be really useful. But in general, I'm gonna discourage you from trying to do too much of your coding in here, right? You can do some testing. We generally call this interactive mode, right? When you're acting interactively, you're putting something in, you're getting an immediate reaction from Stata. But for the most part, when you're doing projects, when you're doing things where you want to be able to execute a set of tasks from start to finish that are going to be like your analysis of the next big data thing that you're interested in, you want to be able to have a recreatable set of steps. And so what we're going to use for that is called a script in general language when you're talking about coding in general. But in Stata, the scripting files, which are just essentially text documents that can be executed by the program. In this case, Stata calls its script files do files. And to open a do file, you type do edit. Don't be surprised that when a window pops up, this is the do file editor. And what you can see is this looks just like a blank file. And that's really good for us. We're really glad to have a blank canvas. And so all I'm going to do here first is I'm going to save this. File. I've got a little folder in here called Stata Tutorial. I'm just going to call this Stata Tutorial do file. Okay. Find a place that you want to put it, and save it there for yourself. Okay, so the first thing I always do is I go down one line for idiosyncratic reasons. I don't know why, and then I indent by one. So I hit tab once, and then I put my name on the paper. Basically, I put my name on this thing, so I know who did the editing. I generally put and sorry, I should say that I put this little asterisk here because Stata needs to be able to distinguish between things that are commands, so things that it should know how to run, and things that are just plain human language text that it's not going to execute, right? So you obviously want to not just be able to write things in Stata language, you want to be able to write things in your own English language so you can keep notes for yourself, so you can be clear about what's going on in your files. These are generally called comments. And to comment your code in Stata, there's two ways you can do it. First is you can put a single asterisk, and that will allow you to start writing. You'll notice that that's turns the text green. If I just start typing regularly, right, if I type something that's very common at the top of a do file, which is clear all, which clears out everything before you start executing your commands, you'll notice that does not turn green because that's a real command that Stata can run. And so if I want to just show that, if I want to run that clear all command now, I've just got these two lines of code. One of them is a comment and one of them is a real piece of code. I can press this little play button inside of the piece of paper, which is also known as execute. And on Windows, at least, you can press Control D, and that will also run. Okay, and you can see that it over here in the results window, it did output some results. So you had it said do, and it executed the do file, and then it had my name, which is commented out, no results as a result of that, and then clear all, everything was already clear, so nothing really happened. But you can see that it executed it in the place that we want. Okay, great. So there's another way to do some more comments. Other comments that I add usually are the date. So I'll say 6/10/2020. And two slashes will also allow you to comment. That's nice because you can also put two slashes after a command has been executed, right? So you can write comments after a command, and I can say something like, "This will clear the entire Stata memory." So that any files that you had in memory will be cleared out. Okay, so basic, very simple sort of thing that we would want to do is put some stuff on our script. Okay, so now the big question is, I've got this Stata program open, but I'm here to play with data, right? That's the thing I want to do, and so I need some data to bring in here, and there's a few things we have to do first. So because Stata, the program, is distinct from the spreadsheets that it works with, it has to know where to find those spreadsheets on your computer. And I'm going to show you a few command line based ways to find spreadsheets on your computer. So what I want you to do real quick is bring up like a folder, like, you know, whatever. I mean, in Mac, it's the Finder. In Windows, it's like Explorer or something. And you can find some different different folders that you have. I'm going to go to the Stata tutorial folder that I have, but find the folder where you saved your do file. I've got a bunch of other files in here, but find the one where you saved your do file. So when I click in here, it's a little different in Mac. In Mac, when you find the place where you found your do file, you can generally right-click, which is also not right-clicking in Mac, but it's command-click or whatever, and find the properties of your folder or of the file, and it can show you the path where it's going from. But basically, what we're looking for is the where on your computer's memory are the files being stored, right? Because Stata talks in computer language, and so we want to be able to speak to it in computer language. And rather than clicking through folders, we want to put where we're gonna point to in computer path terms. This is called your file path. And so so for me, the C drive is the sort of main drive within the users folder, within my folder C Labasi, within the documents folder, within the Stata tutorial folder, is where I want to where I will find the do file that I saved here. And so I just want to give you a sense of how we would sort of look for this or navigate to this folder in a way that didn't involve clicking and taking ourselves to that place. So hopefully you found your your folder by now. And so I want to just quickly show you that I want to show you that we can type into our command window pwd, and that will show us where Stata is currently looking. For me, Stata currently is looking at the folder that I was just looking at, just because I was working in it earlier. But yours probably is something like either your downloads folder or your documents folder. I think Stata by default opens to your documents folder. So that's where you are by default. But if you wanted to be in a different folder, right? If you wanted to change that folder, what you could do is copy the path and type it and put it into quotes. I always put it into quotes just because spaces inside of this sort of thing will really screw you up. But I put it in quotes, and PWD stands for, if I didn't say, it stands for print working directory. CD means change directory. Directory is just fancy computer language for file or folder. So yeah, folder. And so the directories that I'm going to go into is what I'm doing here is I'm saying to Stata, change the directory to C users, C Labasi documents, Stata tutorial, right? Okay. So if I do that and I run that, so I can just highlight this one line if I want. I can highlight anywhere on the line. I'm just pressing Control D, but you could also press this play button here. And so what I can see is that it took in this command and it returned the current path, right? I can also see it down here that's where Stata is pointing to. This is sometimes located or looks a little bit differently on Macs, but the basic idea is the same. And I can confirm that I've been changed to that folder by typing pwd. So if you guys wouldn't mind giving me a few thumbs up that you were able to successfully change your folder to another folder. Okay, I'm seeing some thumbs up. That's good. If not a huge deal, but hopefully you're able to catch up here. So, all right. So we've got a folder that I'm looking at now, and I might a common thing when I open folders on my computer is that I want to look and see what's inside the folder. And the way I do that with a regular Finder is I just like look at it, right? I use my eyes and I look at it because I see a list. You know, there's like a graphical display of the list, but you know, we can just see it in text terms too. And if I just type ls in my window here, in my command window, What I get back is a list of all the files that are in this folder, right? I have a bunch of different files in here for various different reasons, and you know, a lot of these are things we're going to use today. And so I can see different types of files. I see some CSVs, I see some zips, I see some do's, DTAs, all that sort of stuff. So in any case, I've got a bunch of different files in here. I sometimes am just looking for a specific file with a specific name, right? So if I was just looking for the docx files that are in here, I could type ls and then put a star. That's sometimes called as a wildcard. A wildcard means that this text that I'm looking for can start with anything else, but it needs to be followed by docx, right? And so what it does is it shows me all the files that end in docx, but start with anything else. In this case, there's only the Stata error fixing checklist, which I'm going to send you guys so that you can troubleshoot your errors on your own. Not that I don't want to be helpful, but it's very nice to have a set of common things that go wrong for people who are first learning how to use Stata. So I'll send that after the class. But for now, this is one way of looking inside your folder. Another thing you can do is you can put the star sort of after the string that you're interested in. So let's say that I was interested in anything that started with Stata, right? So if I type ls Stata and then star, I see all these things that start with Stata but end with different stuff, right? I've got a docx and then 2 do files, okay? So that's a really nice way to be able to navigate through your file system. But that only matters if you have data that you want to get in. I've already got the data here, but just to help you get data too, let me make this smaller. So a lot of my Twitter networks are people who work in higher education or higher education policy or do research, and so hopefully higher education will be interested to you. There's the iPEDS Data Center, which is really nice. It has a lot of data on it's the integrated post-secondary education data system, and it has a lot of survey data. It collects, you know, mandatory reporting from schools. And if you go to the iPEDS Data Center and you click on Complete Data Files, you can get a lot of different surveys that they produce. Today, I want us to just start with pulling down the institutional characteristics. Okay, so if we click on institutional characteristics and we hit continue, we see a big list here. Okay, and we can limit the list to different years. Let's just go ahead and limit the years to 2018. And so now we just have a handful of data files that we could possibly download. So the data file that I would like us to download here is this Stata data file. It's actually going to end up not being a Stata data file. It's going to be a zip file, so don't be afraid. But if you just click it once, it'll start downloading here. And then once you've got it downloaded, you can, you know, open it up, show it in the folder. You can click extract or unzip. Sometimes in Macs, this requires just, hopefully you know how to unzip a file, but in Macs, it sometimes requires like a double click or something. So I'm going to say extract all. I'm going to tell it where I want it to go. I'm going to choose the file where I've been working all this time. So I've been working in my Stata tutorial file. I'm going to go to 2020. Oh, no, I'm sorry. I'm going to go to just Stata tutorial, and I'm going to select this folder, and I'm going to extract here. I already have this here, so I'm just going to replace the file in the destination. And so now, if you go back to Stata, you should have you type ls, and the file that we had starts with HD. So if I do ls HD star, you should see something like you should be downloading the 2018 file. We're going to download the 2017 file in a little bit, but you should have that there. So I'm going to look for like just a critical mass of thumbs up. That I know that was probably fast, but I'm going to look for a critical mass of heads up there. And if anybody has heads up, let me know. I'm going to try to check some chats while I look for people to see if they're getting it right. Oh, thank you to everyone who's posting the link. Naomi says that on Macs, if you want to run a do file, it's Command-Shift-D. Thank you, Naomi. That's really helpful. Okay, so for downloading, if you're lost on after downloading, we're just moving it. We're moving that. We're unzipping the file that we downloaded to the folder. We're moving the file to the folder where we've been storing that do file. You can put it on any file on your computer, but you can do it there. So I have a folder. My current directory is my Stata tutorial folder, right, which is in my documents and C Labasi and users folders on the C drive, on my C drive. You should check, if you do pwd, see where your Stata is looking currently, and make sure that that matches where you've placed the file that you unzipped. And if you do that, if it is in that same place, then you should be able to type ls and find it there, right? So, okay, hopefully you have it there. And now I'm going to teach you how to import this file. So I'm going to go back to my do file. I've already changed my directory to the folder that is containing the file. And now I'm going to just import this file, right? So I'm going to say import school characteristics file. And I'm going to say import delimited, and then I'm going to put the name of the file, okay? So import delimited HT 2018 stata or data stata.csv. It's weird because they say it's a Stata file, but it's a CSV file, which is different than a Stata file. CSV stands for comma separated values. These are sometimes called comma delimited values files, and so we use the import delimited command, and we're going to say clear at the end. So that means if there's any other data in my current Stata memory, this will make more sense in a second, but if there's any data in my current Stata memory, I want to clear it out. So if I type import delimited HD 2018 data underscore stata.csv comma clear, and I press go, it takes a second, but then there's all of a sudden data in my Stata window. I can tell this a few ways. First of all, I can see that there were 73 variables and 6,857 observations recorded. I can see that I've now got a bunch of different things in this here, and this is called the variable window. So what this does is it gives you an overview of all the data that is stored in Stata's memory right now. I can also see down here in the data window that I have a data set with 73 variables and 6,857 observations, the size in computer speak and memory uptake. So we know that Stata is now contains a file, right? Another way to see that is I can type browse, so browse, and I hit enter, and I get, I'm just going to bring this into the window. I get a file, if I can bring it into the window, let's see. Let's try that one more time. Now I can see what looks like an Excel spreadsheet, right? So when I'm browsing the data, I can see what the data looks like and what Stata is looking at when it sees things. And what we can see here is we've got information on universities, right? So we've got their identifying number, just like your social security number. Colleges have them with the Department of Education and the institution name, right? So Alabama A&M, University of Alabama at Birmingham, Amridge University, yada, yada, yada. We have the address that they're located at, the city that they're located in, the state that they're located in, the zip, right? All these different things, right? We have the name of the chief officer of each university. We've got their name, their title, yada, yada, yada. Lots of different information in here, which is really nice, and we can see that we have data. Okay, so that's the sort of bare bones, most basic thing that you want to be able to do with Stata. which is to import the data. Okay, so hopefully you feel okay. Hopefully you feel okay doing that. So someone asks if there any benefit to doing this way rather than just clicking through the file, import and selecting the file. So the reason I want to emphasize doing it, you certainly can do it the point and click way. There are ways to do it that way. The reason I want to emphasize the command-based way of doing things is that what it allows you to do is it allows you to create this script that you're going to run and rerun. So you can put a command into this script that, when we run this from the beginning, I can now easily press this again, and it reruns, it clears everything out, it changes my directory, and it imports the data again. And that's really nice because if I sometimes need to change where I store the data or exactly which file, maybe I want the 2017 file rather than the 2018 file, I can just quickly make a modification in here and be able to rerun the file multiple times. Long-term data projects often require, I'm sure I don't have to tell many of you, modification, revision, improvement. And so being able to modify your code means you only want to have to change one line and everything else in the process is the same. But if you wanted to, import a different file a second time, rather than just changing one number here, and then having to go through and do all the subsequent steps by clicking again as well, what you can do is just change one number here and then press go, and the rest will execute as well. I think it'll become clearer as we go along. Okay, so that's great. There's a bunch of other commands for importing data. I'm just going to show you. You don't have to worry about doing these. I just want to show you how they're done in case you run into them. So I've got a few other files. I have this scorecard data file that's on my computer. The college scorecard, very much like iPads, relies on a lot of iPads data, is available from the Department of Education on colleges. And if I want, but I have a version that's just already in Stata. If I want to import a Stata file, how do I know what it is? Well, first of all, it has a .dta extension. That's the Stata data file version. So we're going to import that. It has the simplest import command. It's just use scorecard earn small .dta comma clear. And notice I'm using comma clear again because I want to be able to clear out anything that's in my memory already. So right now, what's in memory is this iPads file that we downloaded. And if I were to just if I were to run just use scorecard earn small.dta, it would say no, dataset in memory has changed since last saved. And so what it's telling me is there's data in this memory, in Stata's memory, and if you import this other file, you'll lose that. And so you need to be explicit about the fact that you do want to do that. Stata doesn't want to be blamed for ruining your data. So so you have to be specific about wanting to clear things out. And so when you say use scorecard earn small.dta comma clear, you then see I now have like a earnings file here. Okay. There's some other formats that you might want to import from. So back in the days when we lived in the world where we could see each other and be around each other, I would occasionally do a thing called Park Run, which is a nice free 5K every Saturday. Look it up once the pandemic is over. And they post their data online, and so I have some of it in Excel format. And so I can tell an Excel file by .xlsx or .xls. And if I want to, let me put this in the do file just to practice what I preach. So if I want to import an Excel file, I can do it like this. So you'll notice in the newer versions of Stata, the lines wrap like this. So this is all one line of code, but it wraps down, and you can tell because it's got this little wrapping arrow. If I expand out, it all goes onto one row. In general, Stata only reads what's on one row together. Anything that goes onto the next row is on a different thing. You'll also notice that I indent a lot. I'd like to do that just to keep things clear. I'm sort of like, the main thing I'm trying to teach you is import delimited, but I'm going to show you some other ways of importing data. So I'm indenting that as a way to sort of indicate that. So there's a different option that I've specified with Excel. So I'm still doing the comma clear. That's really important. You'll notice that this is import Excel instead of import delimited. And I'm gonna do clear, but then I'm also adding this first row thing. And this gets back to the differences between Stata and Excel. Because Excel is the spreadsheet, the first row of many Excel files have the variable titles in them, right? So if we go back here and I look at my variables, what I notice is that my variable titles are up here in like sort of outside of the spreadsheet. It's clearly delineated as a different thing that doesn't seem to be a line in the file. But if I were to, I'm just going to quickly comment the first row out. So that's now green. That's not going to be executed by Stata. Just the stuff before these before the 2 slashes is. And so if I do this, it clears everything out fine, but you'll see that I have A, B, C, D, E, F, G over here. And if I browse the data, what I can see is I have a position, park runner time. All of this is in the first row, and these are just labeled with letters rather than numbers. But then we see the real data starts on sort of the second line. And so what the first row option allows you to do is just tell Stata that when you import this Excel file, you should treat the first row as titles rather than actual data. So when I do that, now I see that I get all those things that were on my first line before. They're now in Stata's memory, and this looks like a more normal way of doing things. Just a quick note of when you browse, one thing that you'll notice, numeric variables, so things that only contain numbers, are in black. Sometimes they're in blue. We'll get to that more later, but they're generally in black. And so you can see position and time are all in black here. But then you can also see anything that has non-numeric characters, like park runners' names or age grades, right? Age grades, which here have percent symbols, or there's this dash or VM, right? Whatever. Anything that's non-numeric, those things become string variables, what are known as string variables, and those are turned red. So that's one way you can tell the difference between your string variables and your numeric variables. Let me just check the chat. I need to keep checking the chat. Okay, I think we're okay. Okay, so great. So import Excel. One more. There's 2 other commands that you can do that work just like import delimited. They are import SAS and import SPSS. So I'll put those in the file. They work very similarly. So I have a SAS file that I can do. So I have this random religious affiliation by census or by zip code or something file. And when I do import SAS with comma clear, works just like everything else. Import SPSS works very similarly, but probably you'll find fewer and fewer SPSS files around these days, but you never know. Okay, and there's, I'm sure, many others, so just Google around and see what you can find. So, okay, there's this old joke that a guy takes his motorcycle into the mechanic because it's not working, and he tells the mechanic everything that's going wrong, and the mechanic, sort of furrows his brow, walks up and down past the motorcycle a couple of times, and then kicks it, just sort of in the back third, kicks it, and all of a sudden the motorcycle starts right up. And the guy's flabbergasted. Wow, that's amazing. And the mechanic hands him the bill. And the guy looks at the bill and says, $200 for kicking my motorcycle. And the guy says the kick was free. It was knowing where to kick that cost $200. And so the thing I want to show you now is how to know where to kick here, right? This can be a crude process of learning Stata, but one of the most important things you can know is how to find help, right? How to learn all these different things. And so the most important command you may want to know is help. Very, very you can scream when you say it too if you want. That makes it a little bit more cathartic. But if you want help with a command in Stata, you can write help, and then you can write the command name. So one command that we already did so far was pwd. If we write help pwd, a help file comes up, and it says Stata for Windows, right? And it gives us some information, right? So change directory is what the main thing is, but we also see pwd, and then we get a bunch of information about what these things do. So we can see that Stata for Windows cd changes the current working directory to the specified drive and directory. Pwd is equivalent to typing cd without arguments. These things just show us what directory we're working in, okay? So there's lots of information about how to do it, and then very importantly, there's examples here as well. So why don't we take a look at a sort of more traditional Stata command. If we type help import delimited, we'll see this sort of big, intimidating thing. But the thing I want you to see is that it shows you the basic structure of how the command works, right? So first it shows you the command, right? Import delimited. And then it gives you some options. So there's some optional things here in square brackets, right? So the stuff in square brackets doesn't need to be specified. The stuff not in square brackets is mandatory. So if you want the command to work, you have to put these things in. So what's required here is import delimited and then the file name. This is just what we did now. And then optionally, after the comma, you can do some other stuff. So one of the things you can do is you can write clear, right? That's one of the options. And there's a whole list of other options that you have here. So you could specify a row range. Maybe you didn't want to import all of the data, right? You wanted to just import the first 5,000 lines or something. Then you could write comma row range 1:5,000, and it would give you just the first 5,000 rows, something like that, right? So it gives you all this information that you can learn about. You can also learn about how to export to CSV. You can learn you can learn all about like all the different ways to do this at the menu. So for those of you who are more comfortable at the menu, again, I urge you to just sit with your discomfort with commands and until you feel comfortable with them. But if you insist, then you can find out how to do things at the menu here. There's a whole description. There's links to the PDF documentation, which is much more detailed than the help file. A much more detailed explanation of each of the options and what they do. And then again, to me, especially when I was first learning, the most important thing was finding examples. You can also search through this document. I do Control F. I imagine for Mac users, it's Command F. And so if you wanted to see the examples, sometimes these files are very long. You can, I should probably spell example right. You can see you can see it highlights, and you can go through next and yada yada yada. So if you want to find the examples, I always find it very useful to see examples, see worked examples, and every Stata help file has a worked example. Okay, so we're going to take a quick second to do a challenge. I want you to practice with the help file by checking out the help file of the command we're about to use. It's one of my favorite commands. I know it's deeply weird to have favorite commands, but here we are. And the name of the command is called copy. So what I want you to do is take a quick look at the help file for copy and see if you can figure out what it does. So you're going to type in help copy and then read through it. And I'm going to check I'm going to check the question. I'm going to check the chat while you guys do that, see if you can figure it out. And also, feel free to, if you feel like you've got the answer, feel free to type it into the chat. What you think copy is going to do. You all are apparently reading very carefully, or you can't hear me. I'm having one of those paramount Paranoid moments. Okay, it seems like people can hear me. Okay, great. So Rachel says copy file to another file. That is one of the things that copy does. Yep, that's right. Yep. So make a new copy of an existing file. That's totally right. Totally right. There's one particular use case, one special use case of URLs. And I want to, I see lots of good answers. So you guys clearly are getting a sense of how to navigate this. There's one special use case for URLs that I think is really cool. It's why it's one of my favorite commands, and so I'm going to show you how to do that. So what I want to do is, so one of the things you'll notice in that help file is that it says that we can, that the file path or the file name can also be a URL. And so what I want to do is show you here how to grab the URL where this file is sitting so that we don't have to, I am in the game of getting you to automate everything that you can possibly automate, which means have Stata do the work rather than you do the work. So what I consider you doing the work here is that we just went to this iPad's website and we went and clicked and downloaded and then unzipped the file and then placed it in the folder that we wanted to place it in. And I want to get Stata to do that. And there's a couple of reasons I want to get Stata to do that. A, it's easier. B, sometimes these, your data files get updated from the source, and you want to make sure you always have the most recent data file in your, especially sort of the NCES data tends to get updated a lot. And so if your stuff gets updated from the source, you want to be able to have it. So I'm going to copy this link address. So what I did here was I right-clicked and I got copy link address. You should be able to command click on map. And so now I've got this link address. I'm going to go back to my do file. I'm going to take it here. And what I'm going to do is I'm going to say copy. So we're going to say copying data from the web. And so I'm going to say copy, and I'm going to place this zip file here, okay? And you'll notice that there's two arguments to the copy command. Arguments are just ways that things you have to put in, right? So there's two things you have to put into the copy command. So the first thing is the file that you want to grab, and the second is the place that you want to copy it to. So in this case, what I want to do is copy this file to my Stata tutorial folder. So I'm just going to place this here. And I'm also going to put a new name on the folder. So I'm just going to say institution. You can call it whatever you want, but I'm going to say institution characteristics 2018 .zip. Okay. And what this should do when I run it is it should allow me to copy this from the web and give it this new name. Okay, let's make sure it works. Okay, great. So now I'm in my Stata tutorial folder, and I want to look inside that Stata tutorial folder for any zip files that are in there. And now I can see that I've got this institution characteristics.zip file. Okay, so what that did was Stata went out to the web, grabbed that file from that URL, and brought it down onto the folder that you specified with the name that you specified. Okay, and now that's great. We've got a zip folder, or zip file, but zip files don't really do us very much good. And so I'm going to use the Stata command unzip file to unzip it, and I'm going to just put the file there, the name of the file there. Okay. And so if I run this real quick, I'm just going to highlight and press go. What you can see is it processed one file, it skipped one file, and it extracted 0. The reason for that is that I already have the file out, but yours should look different. Yours should be 101. Okay. And so now if I type ls, I can, and you guys may also already have it because you also already unzipped the file to there. And so now I've got this HD file, and I can do the same import delimited command afterwards, right? And so this to me is a really easy thing to do. You can run the whole thing in a few seconds, and it's much simpler in my mind once you feel comfortable with the downloading. Or sorry, once you feel comfortable with the commands, it's a much easier way of downloading files. Okay. We're going to break in a minute for we're going to break in a minute for a bathroom break, like a 5-minute bathroom break. But before we do that, I want to make sure that I provide you with a challenge to come back from break that we're going to start with when we come back from break. So the challenge is going to be, I want you to, so the iPad's data center has other files, and what we're going to do later in the class today is we're going to look at some of the outcome measures data. Outcome measures is very new data that comes from the Department of Education, and we can see this if we put all years. So I'm going to switch that to all years. I'm going to switch this to outcome measures. And what I want you guys to do is see if you can download this OM 2018 Stata file using the copy command. And so that's your challenge when we come back. I will make sure I'll write that challenge on a slide and have it up for you so you can try it. But if you want to, if you don't need a bathroom break, you can get started right away. And I'm glad to sit here and help you troubleshoot. I see some folks are having trouble in the chat, so I'm trying to help folks with that. So go ahead and take a break. We'll come back at 7:05. Guys, those of you who are having errors, can you copy the command you're using into the chat and paste so I can see it? I just need to see exactly what the command is. Normally, that's the easiest way for me to diagnose. Okay, Nancy. So you need to also specify a place where it's going to go. Naomi, you need to put, so Naomi, you've only specified a, so the double quote might be a problem, but it may not as well. So the other thing you need to do, it looks to me like what you have is a folder called Stata Tutorial 0610. That's fine, but you also want to put a slash and then also give a name to the .zip file. So you have folders right now, but you also need the file name. So maybe something like if you put after it 0610 slash and then iPads data.zip or something, and then close your quotes, that should work for you. Nancy, the same. So the thing that you're missing is one thing you could do is just put a space and a period after yours, and that'll save that file to the current local folder without renaming it. Or you can specify a path like Naomi has here in the chat, and also make sure you give a name to your zip file that you want it to be. Why don't you guys give that a try and see if it works for you? Rachel, I would guess if you had the same error that Naomi got, then you probably have the same thing, a similar thing. Naomi, why don't you try, just for the time being, just to try to diagnose, why don't you try to get rid of why don't you just put the iPads data.zip right after document. So document slash iPads data.zip. That'll save it to the documents folder. But I want to just see if maybe it's a problem with the folder names rather than with your command. Great, Nancy, I'm glad. Theodore, I saw you had your hand raised. I'm going to try to figure out how to answer it. That's interesting. I mean, are you on your personal computer? Do you have the ability to write to your to files there?
Let me just unmute myself and talk because that's probably gonna be
Okay,
easier.
that's probably easier. Yeah.
I am on a personal computer.
Okay. Naomi, why don't you try this? Why don't you, rather than putting the path afterwards, why don't you just put a space and a period? So like the copy, then the URL, then space and a period, and see what happens there.
I think that works now.
Okay, and if you go look, so can you type PWD real quick and see which folder you're in? And if you type ls, do you see the zip, or ls star zip? Do you see the zip file in there now? It should be called HD 2018
Yes.
space data zip. Cool. So that downloaded. So it's something maybe about how you're writing the. Are you on a Mac or are you on a PC?
I'm on a Mac.
Ah, that's what it is. So your documents folder, and it depends a little bit on how modern a Mac you have, because like if iCloud Drive is enabled, it can be a little trickier. But there's no C drive on Macs. And so generally, if you take away the C colon and just do \users and everything else is the same, like when you type PWD, what comes up?
It gives me the folder that I'm in right now.
And does it just say \users as the beginning of it? Yeah, so that's what you want to specify rather than the C colon.
Okay, gotcha.
Okay, cool.
Thank you.
I'm glad we're able to fix it.
Yes, me too.
How do I change the name of the file?
Rachel. Rachel, so what you do, you want to change the name of the file that you're downloading. So you're saying like in the second part of the command, how do you like change what you name it to? So the thing you're writing first is the file path, right? So what drive and then what folders within what drive. And then the very last thing you do is like the last slash. After that last slash, you have like the file name, and there you can write whatever you want. Does that make sense?
Yeah. Yeah, I think that makes sense.
Cool. Give that a try and let me know if it works.
Okay.
Okay, we're at 7:05. I'm going to give folks just another 5 minutes to work on this little challenge. So again, the challenge here, what you're going to do is you're going to, just like we did with our copy command here, let me make this a little bigger. Just like we did with our copy command here, we got this NCES file, this HD file. I want you to grab this outcomes measures file for 2018, get the link, copy it, and unzip it to the folder that you're currently working with. If you have issues, just throw them in the chat or open up your mic and ask me. But if you open up your mic, just tell me your name so I know how to refer to you.
This is Rachel. It worked for me.
Hey, Rachel. That's great. Oh, I'm so glad to hear it.
This is Bradley. Can you put back up your do file so that we
Yeah,
can
of course.
again,
Of course.
please?
Yeah. I'll also show you guys one thing real quick. So Stata, if you don't want, sometimes it's nice to not have one really long line of code all on one line. And so if you want Stata to be able to read across 2 lines, you can put three slashes like that. So I never know forward or backslash. I think that's a backslash. So you can put 3 backslashes like that. And it lets Stata read multiple lines. So then it treats this all as one line. So I'm going to do that just to make it a little bit easier for you guys to read. Just trying to be able to show you guys that. So this is the file that you're looking at. And of course, just while you're working, you can do this with any file on the web. You know, as long as you are able to figure out what link it comes from. They're not always zip files, right? Sometimes you can copy just like a CSV file from somewhere, and then you don't have to unzip it at all. The point is, what you're doing is you're going and grabbing a file, whether it's a zip file or a CSV file or a DTA file. It has a URL that you can tack onto, and you can plug in that URL and then tell Stata where to put it on your computer and with what name you want it to have.
This is Bradley again. So I just want to make sure I understand that you're saying when we use this copy command from a file that's on the internet,
Yep.
and then we read it in, and even though we've unzipped it and it lives in our directory now, it's still going to be like auto updated if that's changed online?
Not exactly. So it's not going to be instantaneous, but every time you run the commands again, it will automatically pull the, you know, whatever's sitting at the other end of that that link. That's the file you'll get. So if whoever's managing the website changes the file that gets picked, you know, that gets downloaded when you click that link, as sometimes happens with iPad's data, then, you know, each time you run your do file, you'll get that most recent version. Also, Bradley, I saw you had an error. Can you just throw the command that you put in into the chat, and I can look at it and see if I can diagnose it?
Yeah, it might be. I'm working on a shared drive through
Yeah.
remote access, and it's probably just not going to let me do that.
Yeah, that's right. Permissions to write can be challenging on work computers or shared drives. All right, so hopefully you guys were able to figure it out. Here's the way I do it. So I'll show you just one more time. So I'm gonna copy the link address. I'm going to go into my do file. I'm going to write copy that. If you just put a space and then a period, by default it'll drop it into your current working directory, so you don't have to worry too much about what the new name is, as that can get tricky, or where you save it, and it'll just save it as the current name. So I'm just going to copy the current name. I'm going to unzip file the current name, and let me bring this up. And if I run these two lines, one thing you can notice is that Stata tells you like how far it is into completing. It sometimes goes a little too fast, and then it wasn't able to overwrite because I already have this file in here too. But hopefully you were able to get that file down. And if you were, we're going to start working with that file. So another challenge is, how do you import that file now? So we're going to look for it. We're going to type ls om star, and it's going to show us all these om files. I've got this OM 2018 data Stata file that is mine, the one that probably the only one you'll see on your computer, and I'm going to import that. Oops, that's the wrong file. Hold on one second. Technical difficulties. Stop sharing. Okay. Reshare. Alrighty, so great. So I've copied, I've unzipped. I see this OM DTA, or sorry, OM dataset.csv. I'm going to import it, comma clear. I got to write import delimited actually. Import delimited OM data.csv, comma clear. Press go. And now I've got 54 variables and 50,000 observations. Okay, so great. That's all good. Let's see if I can minimize that. Okay, and then and so now the thing I want to do is start to play around a little bit with the commands that can manipulate the data itself. So we've got the data in, we've done it in some fancy ways that will make you popular with your friends, and or at least make your friends jealous. And so now we're gonna play with the data. All right. And the most basic command of understanding your data is describe. Okay. This gives us a nice bit of information. It tells us that this has 50,000 observations, right? 54 variables, something that we can also see down here, or we could have seen when we imported. But it's nice, you know, in case you ever forget, it's nice to have. And then it gives us a list of all the variable names, their storage types, the display format, which you don't have to worry too much about, the value labels, and the variable labels, right? In this case, the variable labels are just the same as the value labels, so you don't have to worry too much about that. But we'll in some cases it's useful. What we can see here is the thing I want to show you about describe is that these storage types are useful to know, right? So the basic thing you need to know is that anything that starts with str, whether it's str1 or I think we only have str1 here, or str270 or whatever, all that's telling you is it's a string and it tells you the length of that string. So in this case, it's a string of length 1. So all of the all of the observations in here are strings of length 1. And so great. That tells you something about your data. Why do we care about that? Well, we can't do numerical operations on strings. We can only do numerical operations on numeric variables. Everything else that doesn't start with str, whether it's long or byte or int, right? These are all just different types of numeric data storage. So that's the important thing to know about describe. Other than that, it gives you the simple observations. It gives you some of the descriptions, but it's a nice sort of introductory thing that we need to know. Okay, so so if you want to just describe a specific variable, so I often am wondering if a specific variable is stored as a string or a numeric variable. I can also shorten describe to just DES or DESRC. And so if I want to just specify one of these variables, I can double click up here, or I can start typing the variable name, and if I press tab, it'll complete for me. And if I just do the 1, it gives me just this 1. Okay, great. So great, that's cool, but I want to know actually about some of the data. So what about if I want to take like the mean of a variable? So let me find a numeric variable. Here's a numeric variable, OMR CHRT. I've downloaded the documentation. You can find the documentation as well on the website of the IPEDS data center. But if I look at OMRCHRT, here's the 2010-2011 cohort size, right? So if I'm gonna look at that, I want to type summarize and then OMRCHRT, and I get this little piece of information back. I see that there's 50,004 observations with a mean of 707.4503 and a standard deviation of 2,221.225, a minimum value of 1. So the smallest cohort is 1. The biggest cohort across the institutions is what is that? 120,000, basically 121,000. Okay, that's great. one thing to know is that you can short and summarize to sum, OMRCHRT, same thing, I get the same results. And if I want, I can also get more detailed information by putting the option comma detail. Remember, options come after commas. And so I can see here that I've got a wide range of values that are you know, all the different cohort sizes at all the different institutions. Okay, it's actually a little bit more complicated than that with this data, but we're going to just sort of gloss over that for now. Just imagine as though these are the exact cohort sizes for a bunch of different institutions. Turns out there's not 50,000 higher education institutions in the United States, but there's reasons for that. Okay, great. And another thing that I can do is this nice command called tabstat, which allows me to specify which statistics I want to calculate rather than just getting these sort of default statistics. Sorry, I should explain this in better depth. So there's the mean, there's the standard deviation, observations, the variance, the skewness, the kurtosis. There's the 4 smallest observations here. There's the 4 largest observations here. And then you get to see a bunch of select percentiles. So you see the 1st percentile, the 5th percentile, the 10th percentile, the 25th percentile, 50th, 75th, 98th, 95th, and 99th, right? Those can be really nice for having a sense of the distribution of your data. Okay, so if you want to see the specific statistics that you want to calculate, if you use tabstat OMR cohort, by default, it gives you the mean, okay? But if you want to specify a specific statistic that you want, you can say tabstat OMR CHRT. Remember, OMR CHRT is just the name of the variable. So remember, it's the thing you want to do and the thing you want to do it to. So we want to take the tabstat of OMR CHRT. And then in the options, I just type stat, no space, a parentheses, and then I list the stats that I want. So if I still want the mean, but I also want the n, I do that, right? And so now what it gives me is the mean and the number of observations. Just you can see it matches this up here as well. Bradley, I'm just seeing your question that when you click on a specific command, it's not just that you click on a specific line, you have to highlight that line if you want that to just work. And I apologize, I should be putting these in my do file. So I have summary statistics, sum OMR CHRT, and then I also have some OMR CHRT comma detail, which also can be shortened to just comma D. And then I have tabstat OMR CHRT stat parentheses mean and n. Okay, great, I've got that. And then if I do tabstat, oh, I should spell it right, tabstat OMR CHRT comma stat, and I'm just going to show you a bunch of the different ones that you can do. So mean, N, SD, SEMEAN. Let's see here. I think I can do P25, P50, P75. That's the 25th, 50th, and 75th percentiles. I can do min and max, right? And so if I run this, it gives me all of the values for those statistics, right? So now I've calculated all these things. Okay, that's great. I can also, the really great thing about tabstat is that I can add a by statement to it. So that means I can look over some other variable. So if I look at, it turns out that this variable, I'll show you tabulate real quick. So tabulate is a great command that shows you the different tabulations of different values. This is just like a cohort type. It turns out 50 is the totals, so there's really only 3,000 schools in here that have totals. 50 is the totals, but there's, you know, some of them are just specifically for Pell students, and some of them are for non-Pell students. There's a bunch of different group types here, And so we could do it by the different group types. So if we say, let's just do stat mean and n, or let's just do mean for now, and then we type by parentheses, and we're going to say OMCHRT. It sort of stinks that these variables are so similarly spelled, but I swear that there's an R here and there's not an R here. So these are two different variables. And if we do tab stat and by this, what we can see is here's the mean for each of these individual groups, right? So this is the mean cohort size across all these individual groups. You can see it's much larger for the totals than it is for some of these other subgroups. So that makes some sense, right? Tab stat is really nice for that by option. And so, okay, great. So now what I want us to do, just as a little test, is to import again the original HD file that we downloaded. So remember we downloaded the institutional characteristics file first. So if I type ls hd star, I see this HD 2018 file. I want to import delimited that. So why don't you take a second and import delimited that? Well, I see I have a chat, so I'm going to check on that real quick. So see if you can remember how to import that file using import delimited. I want to heartily endorse Bill's suggestion that we need common language variable names. It's very true, especially with NCES. Annie, you might be having trouble because your file, you might be pointing to the wrong place. So if you type pwd, just make sure that this folder matches the folder where you think it should be showing up. Okay, so hopefully you've been able to figure out. It's good to spiral a little bit. It's been a minute since we did the import delimited, and if you come away with one thing, I want you to be able to import files at the command line. So I'm going to import delimited HD, whatever this is called, HD 2018 data stata, and I've got this now imported, okay? And I'm going to show you some other things that we could tabulate. So, so we showed you a little bit tabulate before, but I want to show you it again. So here's tabulate STABBR, just because I think this is a little more intuitive. So, okay, what this is, STABBR stands for state abbreviation, and you can see Alaska has 10 schools in this file. And it accounts for 15% of the, or sorry, 0.15% of the schools in the file, of the observations in the file. There's Alabama has 90 schools in the file. Arkansas has 87 schools in the file. American Samoa has 1 school in the file. Okay, and we can see there's some bigger ones and some smaller ones, and it's a little, right now it's in alphabetical order, but we might want to have it in frequency order. So if we did that, if we type comma sort on the tabulate command, we can see the results in frequency order. So California has the most schools in the file, New York has the next most, Texas has the next most, followed by Florida and Pennsylvania, okay? And you can see that California accounts for 10.5% of the schools. These are known as frequency distributions and percent distributions. Tabulate is how you get them, okay? So to reinforce one more time, I know this is annoying, but it is, I promise, practice that I hope will help nail import delimited into your brain. We're going to try to switch back import delimited. We're going to switch back over to the original, to the OM file. So this is the outcome measures file. Hopefully you're getting the hang of it by now. Import delimited. Okay, now I'm going to show you how to install user-written commands, right? So Stata designs a bunch of commands itself, right? It says this verb means that Stata will execute this task, but occasionally Stata users find it wanting, and so they write their own command for their own task that they want Stata to do automatically. And if you're a regular Stata user, when you buy Stata, you don't get those user-written commands. You have to explicitly choose to add them on. And so there's a way to do that, and often it is ssc install, and then you can write the name of the command that you want to install. So I want you to do ssc install mdesc, that stands for missings describe. So one of the most important things you can have in a data set is an understanding of its missingness, why and where data is missing. MDesc won't tell you why the data is missing necessarily, but it will tell you what is missing. And so if we type mdesc and nothing else, what this does is it gives us the number of missings that are in your data. So so I'm going to give you a second to just catch up while I look at some of the chats that I've been missing. Okay, we're good. Okay, so if I look through this, I see I have nothing missing on the unit ID. I have nothing missing for lots of them, but then I have a bunch of 17,000 observations that are missing for a 4 years bachelor's degree. This is the count of students who have received a 4 years bachelor's degree. So there's 17,000 missing here, and I see there's 16 missing of this variable and 17,000 missing of this variable and 16 and 7. So I can see all the places where they're missing. Okay, that can be really useful. But one thing that can be kind of annoying about MDesc is it only shows you the count of the missing and the total and the percent missing, but then you have to kind of do the math if you want to know the count of the ones that are present, right? And so there's another user-written command that does a pretty good job with this, and its name is tabmiss. But unfortunately, if you type ssc install tabmiss, that will not install it. For some reason, it has a different ssc storage name, but luckily Stata gives you this thing that you can click on where you say search tabmiss. Stata will search for tabmiss for you, and then when you click on it here, and then click here to install, you can install it and have it on your computer. Once you have it on your computer, you can say tabmiss. I should spell it right, tabmiss. And then you see this thing I was telling you about, right? So now you not only have the number of observations, you have the frequency of missings and the percentage of missings, but you also have the frequency of non-missings, so you don't have to do the math yourself, and the percentage of non-missings, right? So what this tells you is that this is 64.8% present. Bradley, you only have to install it once. As long as it's installed on your computer, and as long as you don't go and delete the files, which would be hard to do, it will stay on there. But it's also very easy to get it if you don't. Okay, so there's this other Stata missingness command, and we're going to give you a little challenge here to learn how to install this other Stata missing command. It's called mv patterns. I want you to use what you know, what we've just learned, to try to install mv patterns on your own. I'm just going to take 30 seconds to do this. Do some folks want to give a thumbs up if they were able to successfully install mv patterns? Okay, I saw one thumbs up. Hopefully this is just a sign of people starting to get hungry for dinner or something, and not everyone falling behind. But if you just type ssc install mv patterns, you'll notice that didn't work, but it's a good way to start and try. when you search for MV patterns, you can click this here. You can click here to install, and then you should have MV patterns. MV patterns, if you type it, will spit out something that looks a lot different. So this time it tells you the variables that have no missing values. So this is a nice list of variables that are always present. And then here's the list of variables that are missing. It tells you similar things, how many are there, how many are missing, although they're a little squished together. But then what's kind of cool about it is it tells you what the patterns are. So here, this is the order of the variables, and then plus means it's there, and dot means it's missing. And so the most common pattern is that everything's there. Some observations have missing, plus, missing, plus, missing, plus, 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 right? You can see the different things, and you can see the number of missing values. You can see that there's 3 missing values in this specific order, or 7 missing values in this specific order, or then everyone's missing, and you can see how frequently that happens. Okay, great. That's all you want to know about missingness. That'll help you explore missingness. Alrighty, so let's see here. So let's take a brief interlude to talk about mathematical operations in Stata. So so you can use Stata as a, I think I got a few chats before I go on. Thank you, Bradley. I appreciate you helping folks out. Stata can be used as a calculator, and the way it can be used as a calculator is to use the display command. So if we say display 10 plus 2, we get back 12, right? If we say display 10 minus 2, we get back 8. We say display 10 star 2, we get back 20, because that's multiplication. If we say display 10 slash 2, we get back 5, because it's division. If we say display 10 caret 2, we get back 100, because that's squaring 10. If we say display, you'll notice that I've started shortening display to DI, which you can do. So display square root of 10, you get 3.16, okay? If I say display ln, the natural log of 10, right? So lots of different mathematical operations that you can do, which is really nice. You can also do logical operations. So you could say something like display 10 greater than 2. So 10 is greater than 2, so it returns a 1. So 1 for true, 0 for false. Display 10 less than 2, 10 is not less than 2, so you get 0. Okay, that's good to know. What about testing if they're equal? So we say display 10 equals 2. In Stata, if you're testing whether two things are equal, two quantities are equal, you use a double equals, and you say display 10 equals 2. It does not equal 2. What if we say display 10 equals 10? We get yes. Okay, what about greater than or equal than? So display 10 greater than equal to 2? We get yes. What about display 10 greater than equal to 10? We get yes. What about display 10 greater than 10? We get no, right? So this greater than or equals to gives us a useful tool, and that allows us to include the equals. This will work the same way for less than. So what about display 10 less than 10? No, it's not. Display 10 less than or equal to 10. Yes, it is. Okay. We can also do this with strings, but we have to put them in parentheses. So if I say display quiet quiet, quote, double equals, quote, quiet, quote, and then I close the parentheses, I get back a yes. But just to give you an example of how strict Stata is about strings being matched, if I just change the uppercase quiet to lowercase quiet, it does not return a 1, it returns a 0. Okay, so that's all fairly useful to know, just because this will help you figure out how to put conditions on things later, this logical stuff. So we're going to do that in a second. Okay. Now let's move to some things that we can do with these conditions. Oh, I'm sorry. One more thing I want to add. I knew I was forgetting something. Is we can combine these with and or operations. So if we want to say display 10 greater than 2 and 10 greater than 5, this will be true because 10 is greater than 2 and 10 is greater than 5, right? Now, if I change this so that I say 10 greater than 2 and 10 less than 5, 10 is greater than 2, but 10 is less than 5, so this is not true. This one's not true, which means that the two of them together are not true, even though one of them is true, okay? So if either one of these is false, then the and statement does not evaluate the true, it evaluates the false. And if but if I wanted to say if either of these are true, we could use an or symbol. The or symbol is a straight up and down line, which is sometimes called a pipe. For me on my PC, it's above the forward slash, I believe, above the enter sign. It's just a straight up and down line, or enter key. It's straight up and down line, and if you press that, so now this evaluates to true because this stands for or. So display 10 greater than 2 or 10 less than 5. So we're saying is 10 greater than 2 or is 10 less than 5. This one evaluates to true, so the whole thing evaluates to true. This will turn out to be useful in writing conditions, okay? So to ease us into, let me quickly check the chat, but to ease us into can I check the chat? Let's see. I'm gonna stop the share real quick. Restart the share. We're losing people. We're losing people. Okay. All right. We seem to be good on the chat. So, so a command that I promise in a second we're going to use conditions for that can be really useful is the drop command. So if you want to get rid of a variable or an observation, you use the drop command. But you want to be careful about this. Deleting data is always a very serious thing. So you want to be careful about it. But if I want to just, let's say I don't care about these X variables are imputation flags. Very important to pay attention to if you're doing serious work. But for right now, we might not care about them. And so we might want to drop one of these imputation flags because I don't care about it. It starts with an X. And so if I just say drop X, I can see now that variable's gone. And it just dropped it, no problem. Okay, I can do that. I can put in multiple variables. So I've got a couple other, let's say I've got a couple other I want to get rid of. I can list all three with drop. Great, that's no problem. And then I will also, but I can also use the wildcard that we've been using before. So if I say drop X star, so it means anything that starts with X and ends with anything else. If I say drop X, now all my X variables are gone. Okay, so that's a nice thing. Another thing that's really cool is there's an opposite. Really cool is an exaggeration. Forgive me. So keep is the opposite of drop, and this is when you want to specify not what you want to get rid of, but what you want to hold on to. So maybe we would say keep unit ID and just like a couple variables that we're interested in. So maybe the 4-year certificate rate, the 4-year associate's rate, and the 4-year bachelor rate, as well as the unit ID, the identifier. What we can see here is that this gets us just a few variables, and now when we browse our data, we have just a few variables left, okay? And so that's a good way to pare down your data. Bradley, there's not an undo, and that's, to me, probably the biggest argument in favor of a do file is that if I'm doing these things in my do file, it's very simple for me, including the downloading thing. It's very simple for me to just go back, press import delimited again. I get the fresh file back the way I wanted it, and it's back the way it was. Christopher, I don't think that it's automatically saved. That's why it's a little bit of dangerous territory. But ideally, if you're writing a do file, you should be able to quickly get back to where you were. execute all the steps you'd gotten up to the point where you executed the command that you wish you could undo, and then it'll be just as though you hadn't done it again, right? That's why I like to think of this process as a scripting process where you write down what you want to do in order, because then it's trivial to get back to where you were before without having to have an undo. So okay, great. So we've done that. But we also, I promised you some conditions. So what if I want to not delete variables but delete observations? And in fact, I am going to re-import. You guys should too re-import your data so we can do some of these other things. So what if you wanted to keep just specific observations? So if I tab one of these x variables, I'm going to do this xom rchrt. I should get rid of this. I can see that there's a couple of imputation flags. There's a C, there's an N, and there's a P. These are just different reasons that the data might have been changed. One of them is a carry forward, one of them is an imputation, and one of them is something else I forget. And then this is all regular data, right? And what if you just wanted to get rid of any data that that was a carry forward or something? I think carry forward was P. So so if I said keep, or as I'm saying drop if, so the if statement is really key here. So what you're saying is I want to drop observations that meet certain conditions. So I want if I want if I say, if I go over time, then hit me or yell at me. You don't get to hit me or yell at me if I don't go over time, but if I do go over time, you get to do it. So what this is saying is I want you to drop any observations if their value for XOMR CHRT is equal to, let's say, P, right? So for all the observations where they're I have to specify that. Sorry, drop if XOMR CHRT equals P. Okay, great. If I do that, I see that there are 22 observations deleted. That's very reassuring because we see here that 22 of them had a XOMR cohort imputation flag of P. Okay, a couple things to notice, right? This evaluation is just like the evaluation we were doing up above, right? So Stata is asking a question, is this true or is this false? At each row. So it looks through each row and it says, if this value is equal to P, then drop it. If it's not equal to P, then don't drop it. So 22 times, this came up a 1 rather than a 0, and Stata deleted those 22 instances. You'll notice we use the double equals here because we're testing whether or not this logical statement is true. And because this is a string variable or a string thing that we're interested in, so this XOMRT, if I describe it, I know I'm not saying the right letters, but just forgive me. If I say describe on that, it's a string of length 1, right? Because these are all letters and they're all of length 1. And so because this variable is a string, the thing that I'm testing against has to be in quotes because strings go in quotes, basically. And it sort of makes sense. If you think of it as we're using words, it makes sense that they should perhaps go into quotes. Okay, so I've got that. I've dropped these 22 observations. That's really nice. It turns out we can of course do this for evaluating other things. So maybe if I wanted to drop like the really small cohort sizes, I would say drop if let's do OMR CHRT less than 10. Okay, and what this is going to do is for anything that has an OMR CHRT value less than 10, it'll get dropped out of our data set. You can see that there were 5,000 observations that were less than 10, and they got dropped. Okay, so now our variable, our observation size has changed. Garrett, I don't have like so Garrett asks, I always get confused on double equals or just equals. Any tips to remember when to use them? I don't have a great mnemonic, but the thing to know is that double equals is testing whether or not things are equal. Single equals is setting things equal to something. So we're about to learn in a few seconds how to create a new variable that has new values that you assign to it. If you're assigning those values, you are using a single equals. Double equals is testing whether or not something is equal. I'm sure someone could think of a good mnemonic for that, and I probably should, but I haven't just yet. Okay, so I told you before that this OM cohort variable gives us some knowledge. So if I tab OM cohort, not to be confused with OMR cohort, this tells us some different data types. I can actually show you this in a second. So so imputation values, no. Frequency. So what you can see here is that if the OM cohort value is 50, then that's the total for all students at a school. If it's 51, that's it's the total for all entering students in a given cohort at a school. If you're looking at the code 51, you're looking at the Pell Grant recipients. If you're looking at code 52, you're looking at the non-Pell Grant recipients. There's some, the nice thing about the outcome measures that a lot of people like is it doesn't just give you, for those higher education policy wonks among you, it doesn't just give you the first-time full-time students, right? So if a student transfers or if a student has dropped out before but is coming to college again, you might want more than just the first-time full-time students. You might also want part-time students, right? So this it gives you lots of different data groups with first-time full-time, non-first-time full-time, first-time part-time, right? All these different things. And it also breaks those out by Pell Grant recipients, lots of different subgroups. This is great data to have, and very grateful to NCS for providing it. But in this instance, we just want to, for our purposes, focus on just the total entry, right? So if we only want to keep those data points that are the total entering, what we could do is we could say keep if OMCHRT equals 50, right? Because we remember that 50 told us that those were the totals. So we're just keeping those observations. And now we have a data set of 3,773, and that's a great thing to have because it gives us the totals, right? So there's 3,000 observations for whom we have this information. Okay. Now, if we want to generate a new variable, so we've got the variables that the Department of Education gave to us, but we might want to make some variables of our own. And so if we wanted to do that, so for example, we've got these, now I've got the totals, so I can look at the cohort size and it could be something meaningful. So if I do sum OMRCHRT comma detail, I see that I remember that I dropped out anyone who was lower than 10 before. If yours doesn't look like that, that's okay. But if I dropped out all the other ones, then I can see the distribution of sizes here across the group. And I now know that these are the real cohort sizes, the totals across institutions, right? So there's some institutions in our data set now as small as 10 students in a cohort, and there's some as big as 120,000. I think that's usually the University of Phoenix that reports all of its stuff together, but I could be wrong. Maybe some other big for-profit chain. Okay, so we see all these different things, but some of these numbers are really big, and Stata doesn't display them with commas, so it can be a little challenging. And so maybe I would want to have my data in the form of thousands of students rather than in the raw number of students. So I could generate. Sorry, Naomi, I'm just reading your thing. Interesting. Naomi, my only suspicion is that maybe you're using OMRCHRT rather than OMCHRT. Yeah. Just so OMCHRT has the has the code, you know, that's this one, and then OMRCHRT has the has these the full distribution of sizes. Okay, I'm getting delirious here. So all right, so if I want to create a new variable that stores the values in thousands, what I would do is type generate. Generate is how we create new variables. Part of me thinks this should be called like create var or something, but it's generate. And then we get to name this variable whatever we want. So in honor of Bill, I don't know if he's still on, in honor of Bill, we're going to make this nice and readable. So we're going to say cohort size in thousands equals, and then what we're going to do is we're just going to take this OMCHRT variable, OMRCHRT variable, and divide by 1,000, right? So what this is going to do is it's going to go into every observation, take the value that's there for that observation, and divide it by 1,000. You can think of the equivalent in Excel being if you like went to one cell and then put you know, equals that some other cell to the left divided by 1,000, and then did that repeatedly for every cell, right? So that's the equivalent here. So we generate cohort size in the thousands, and I divide by 1,000, and I've got this new variable. If I look over here, I see I've got this new variable, exactly what I called it, cohort size in thousands. And if I browse OMRCHRT and cohort size in thousands, I can see just these two variables, and I can see, okay, yes, in every instance, it's that variable divided by 1,000. That's really nice to see. And so if I do summarize cohort size in thousands, comma detail, I can see it's the same looking distribution, just everything's divided by a factor of 1,000. And so now I can say there's 120,000 in the biggest school, there's 24,000 in this 99th percentile school, the 90th percentile is 5,000. Okay, you might want to do something like that. It's nice to be able to create a new variable. Let's see here. So here's a quick challenge for you. I want you to create a new variable. There's no reason that you would do this kind of thing, but just to show you, you know, try to test you out a little bit. Create a new variable that's equal to the OMR cohort, the same variable that we were just working with, that's equal to that variable minus 37. So you just want to subtract 37. So you're going to create a new variable. Look at what I did, create a new variable, and subtract 37. And then maybe throw some thumbs up when you've got it, or type into the chat, whatever works for you. I see a few thumbs up. Okay, so here's how you would do that. You would write something like generate OMR cohort minus 37 equals OMR cohort minus 37, right? Hopefully pretty self-explanatory. But you know, the things that you might get tripped up on in that situation are, you know, you've got to figure out what to name your variable. You've got to make sure you've got just a single equal sign here. And then, you know, just feeling comfortable using the right variable and all that sort of stuff. Okay, one last thing before we take a bathroom break is we're going to learn how to save our file. So we've made a bunch of changes to this file, and now we want to save it. And we presumably want to save it as a Stata data file. So if we say save, and then I'm going to put in quotes the path that I'm in. So first of all, let me bring back up my path so I can see it. So I'm going to say save, and then I'm going to type C users C Labasi documents data tutorial, and then a slash, and then I'm going to save this as my iPad's cohort data.dta, and then close quote, and then comma replace. I use the lowercase letters for variable names and the underscores. First of all, there can be no spaces. That's a hard and fast rule. There can be capitals. It's just convention not to have capitals, I think, because capitals, I mean, it's not always true. You'll download plenty of data sets that have capitals in them, especially if you're importing data sets from Excel. If you, I think in general, people are lazy and don't want to have to keep track of what's uppercase and what's lowercase. And because Stata is so prickly about making sure you get uppercase and lowercase right, I think everyone tries to make it so that their stuff is always lowercase, so that you don't have to really think twice about it. That doesn't solve all the problems, but it helps solve one problem. But the underscores are there because you can definitely not have spaces in between. Okay, so if I'm going to save, the reason I put this all in quotes is, like I said, with paths, a space like in Stata tutorial, like I have here, is going to cause a lot of problems, but it doesn't cause problems if you put and close everything in quotes. Remember that Stata data files finish in DTA extension, so .dta, and then I have this option of replace that comes again after the comma. Remember, unlike traditional American English, standard English quotation rules, the quote goes before, not after the comma, right? So close the quote and then put the comma, because otherwise Stata will read the comma as a part of this big string that it's going to use, and you don't want that. So this is outside of the quotes, and you're going to use the comma to try to specify your that you're going to use an option, and then the option we're going to use here is replace. That if you've ever tried to save a file that of a name that already exists on your computer, you know that, like, Microsoft Word will say, this file already exists. Would you like to keep it? Would you like to change the name? Would you like to replace it? And so you something very similar is true, that if you have to tell Stata to overwrite a file of the same existing name, right now this is going to tell me this is just a note. It says we didn't find a file that already has that name. Because I put replace, it says I was looking for a file that already has that name because you told me to replace it if it does, but we're just noting that it doesn't have that. And so because it doesn't have that, it just saves it fine, no problem, no issue. And if I type ls.dta, I can see I now have that DTA file in my folder. Okay, so great, I've saved that there, and now we can take a break because we've saved our file. We feel good about it, and we'll come back at, let's say, 8:07. If you guys have any questions in the meantime, please feel free to open your mics or ask me here, whatever works for you.
Hi, CJ, can you hear me?
Yes, I can.
Okay, this is Annie.
Hi, Annie.
Was not able to unzip my folder or my data, and I'm not sure. It says that it's going through successfully, but when I'm on a Mac, when I'm looking at it in the folder, it's not actually coming through as unzipped.
Interesting.
And then when I even try to do it like manually, it's not really working either.
Interesting.
Yeah.
Zipping can be tricky. Does Stata give you an error when you type unzip?
No, it says successfully unzipped. But then when I go to import the file, it says that the file cannot be found.
Interesting. So when you type ls on your Stata, does it show the files then?
Yeah, it does.
And what CSV file? So is this the HD one or the OM one that you're talking about?
The OM one
The OM one. And does it have a does it have a CSV for the OM one? Or does it just have the zip?
No, it just has the zip.
Okay.
Or I got one that had a .do in one try.
So that's your do file. .do is your do file that you're writing in, presumably.
Okay.
So I know that you've already done this, but just so we can double, triple check. Can you type unzip file? Actually, why don't we try this? Can you just try typing shell? I'll show you here. So if you type shell, I don't know if this will work on a Mac, but if you type shell space unzip and then type the name of the zip file,
Okay.
see if that works. I don't know if it will.
Hold on, sorry.
That's okay, take your time.
Saying replace OM 2018.do question mark. Yes, no, all, none, rename, null, EOF, or red error, treating as none.
So is that in Stata itself, or did another window pop up that,
No,
like, is asking? That's within Stata?
Yeah.
Oh, interesting. Why don't you just say no or N or whatever?
Okay.
Okay, can you write unzip file again?
Yeah.
And then list the name of the zip file?
Yeah, it's saying successfully unzipped to current directory.
And then in that, let me see if I can find an example. So there should be like a little summary of what it did, and did it tell you like skipped or anything like that? Like, it says like skipped, and I'm trying to find an example.
Yeah.
What does it say?
Saying total processed 1, skipped 1, extracted 0.
Yeah, so it's not extracting it for some reason.
Okay.
Why don't you try this? Why don't you go back to the website?
Yeah.
Or you're doing it with the copy command? Is that right?
Yeah.
Or were you doing it with doing it manually?
No, I was doing it with the copy.
Were you able to do it successfully with the HD file?
Yeah, that one worked just fine.
That's interesting. Why don't you go back to the website and get the URL for like the 2017 version of the file?
Okay.
And see if that works. Otherwise, it might just be worth like deleting all the versions. Like sometimes they corrupt when they're downloading. I don't know why. And maybe you could just like delete them out and try running it again.
Yeah. Okay, so it said it copied.
Okay. And then can you try the unzip file thing? Are you doing it with like the 2017 file?
Yeah.
Okay, great. Why don't you try that with the 2017 file, and then look at the output and see if it tells you if it skipped it or if it didn't.
Yeah, so it's saying total processed 1, skipped 0, extracted 1. Is that what
That's
it's supposed
great.
to say?
Yeah,
Okay.
and so if you type ls now, you should see like the 2017 version there in a CSV.
Okay, yeah, I do.
So it must have been a corruption thing. So what I would do is delete out, like just go into your, actually, if you're interested, if you just type rm and then list the name of a file you want to delete. So like if I were to say rm my iPad's cohort data or something here, it'll delete it and then it's gone. So you could try doing that too.
Okay. All right, thank you.
Yep, no worries. All right, it's 8:07, so let's kick back in. Team, I'm going to be honest with you here. I think we're not going to get through everything. This is taking longer than I expected. I probably should have expected it, but we're trying to cram in a lot of stuff. I'm trying to think while teaching about what to do about that fact. I am totally glad to offer a second class that covers the stuff that we don't get to. I am also open to, I don't know, other suggestions. So if folks have suggestions about what to do, I'm glad to, I think I can also, I think the two real viable options are do a second class, sometime in the next week or two, or just try to focus on certain things that people some things that people are most focused on. So Garrett suggests that okay, so I see a lot of talking about second class. I'm glad to do a second class. So why don't we do that? And Garrett's right that these are a little bit more intermediate. So maybe what I'll do is I'll try to do the second class before the advanced tutorial. So that way people could get the intermediate. I think the advanced is still going to be a little bit of a jump for folks, but at least if you're sort of trying to follow an order, that would make that would work. So so yeah, we'll do that. I'll reach out about that, and then I don't have to feel stressed about pushing us through everything towards the end. So so we'll do a second class. I'll send out a little survey and see when folks have time, and we'll try to make it work. Okay, so all right. Let's see here. So a few things that we would also, okay, so we've saved our file, and I'm gonna just one more time, and maybe at least one more time, ask you to practice your importing skills, and I want you to go ahead and import again the HD file. Okay, so the HD file is the institutional characteristics. You're gonna use import delimited to import that file, and then hopefully you'll be able to get it in. So I'm going to import the file quickly. Plug in my laptop so I don't die. All right. Okay, so once you've got that file in, we're going to do some even more fun modifications to the file. Again, fun being, your mileage may vary. Okay, great. So we've already created a variable, but we've created a numeric variable, and we might want to create, instead of creating a numeric variable, we might want to create a string variable, right? So remember, string variables are the kinds of variables that have, non-numeric characters in them. And we might want to create one just because those are sometimes easier to read. And so what if we created a variable that kept the region of the United States in it, so that the school is from, right? So you'll remember in this file we've got the tab stabber, and we've got this list of different states, right? And so maybe we would want to study these schools by region, right? And we would want to be able to define the regions ourselves because no one can agree which states are in the Midwest, and so we want to, define our own regions. And so we're going to say gen, which is just short for generate, right? You can do generate, but you can also do gen. Also, before I forget, can someone stop me at like 8:50, and we will, I will show you a few resources that are good, just on the web. And I want to make sure I do that before I close out. So just make sure I do that if you can. Okay, so gen, short for gen, a short for generate is gen. It's often how you'll see it in people's do files, or at least in my do files. So gen region, and if I want to initialize just a blank string variable, I'll open a quote and immediately close the quote. Okay, so if I run that, I get a blank variable. So if I browse, let's say unit ID, stabber, and region, I see that there's all these different variables here, but this is always blank. Okay, so all I've done is created a blank variable, but what you'll notice is if I describe region, I see a string of length 1. And so I know that I've successfully created a string variable. And so now what I want to do is figure out when I'm going to, under what conditions am I going to assign someone to the west? Okay, so all right, let's pick a state that's in the west. Here's a good choice, Wyoming. So if I want to make sure, I want to make sure I assign all the variables that are in Wyoming, or sorry, all the observations that are in Wyoming to the west, I will say replace region equals west if stabber equals WY. Okay. This is a great, I forget who it was who was asking before about, I think Christopher was at, or no, maybe, I don't know, was asking about when to use equals and when to use the double equals. So here's a great use case for it. So when we replace the variable called region, we want to replace the values of region, which are now currently blank. We want to replace them with the word west for all the observations that meet the condition of the state value being equal to Wyoming. Okay, so if your state value is equal to Wyoming, then I want you to replace your value for region to west. Okay, so if I just highlight this and run it, I can see that there was 10 real changes made. That's reassuring because there was only 10 Wyomings, and so it should have only done it 10 times. Another thing you'll notice is that region was string 1 and now it's string 4. That's because west is a string of length 4, and the length of the variable has to be at least as long as the longest string, and so, or as long as the longest string, and so so you'll say so now this is west. Okay, great. But what if I wanted to like do it for more than just one variable or more than one state? There's more than one state that meet here. So I would want to replace it if its state is equal to not just Wyoming, but also let's say California, right? So stabber equals California. Okay, so what did I do here? I'm typing kind of fast, but I said replace region equals west if state abbreviation is equal to Wyoming or state abbreviation is equal to California. So when you evaluate a state and what its value is, if it's equal to WY, then yes, we change it to west. If it's equal to CA, then yes, we change it to west. Either one of these has to be true. Both of them doesn't have to be true, right? Because obviously it couldn't be the case that they were both equal to Wyoming and equal to California. Okay, so if I run this, now I see I've made 720 real changes. Okay, nothing is getting changed about the Wyomings because they were already called west. So this matches the California count of 721 schools. So that makes sense. Okay, great. So so we've got two things down here, but this is still going to be a pretty tedious process of just like adding on stabbers here. And so, you know, if I was going to add on Nevada or whatever else, but there is a nice little shortcut for situations like this. So if you've got a long list of states that you want to add on, you can use this nice function called inList. So we're going to say replace region equals west if inList, that's all one word, open parentheses, and then we list the variable that we want to check. So we're going to say stabber. So we're going to say if the value for stabber is in this list that I'm about to give you, then the condition is equal to 1, and we're going to set this equal to West. So if stabber is equal to Wyoming, or it's equal to California, or it's equal to NV, or it's equal to OR, or it's equal to AZ, or it's equal to MT, right? You could go on and on and on. One problem is that there's a limited number of these things that you can list, so you can't list them off into infinity. I think the max is like 8 or something, which is actually kind of low. But if you do get into that situation, I'll show you what you can do. So, all right, so we did this. It made 282 real changes because we've already done Wyoming and California. So what we're doing is we're changing these things here. And if I go back and I browse now my region and my stabber, I can see AZ, all the observations in AZ have been set to West. I didn't include New Mexico, although I could, and so it's not set to West. Arkansas, not set to West, right? But California is set to West. Okay, so it's following the logic, which is very nice. Okay, so if you do get yourself in a situation where you've reached the limit and you need to make another in-list thing, you can just do OR and then add in-list again, and do something like what else is out there? So we said NM and CO, and there's probably others. What am I not thinking of? WA, right? And so you add this list. And so now we've got, this is how we sort of, this is a little bit of a hack to get around the fact that there's a limit on the number of things you can include in this, in the in-list command. But we do that, and so now we get another 273 changes. Okay, and so this is great. We've got a nice way to change this. And what I'm going to do is now challenge you guys to do the same thing, but do it for a region of the country of your choice. So, so you know, and you can. It doesn't really matter which states you choose to place into that region. So let's imagine if you were going to do replace region equals Midwest, right? And then the if statement that you would do there. So go ahead and take a let's say 3 minutes to do that. Feel free to ping me with any questions you might have. All right, so I guess it really hasn't been 3 minutes, but can I see just any thumbs up if folks have successfully done that? Great, looks like folks have done that. So great. So so that's how you would create a variable, that very plausibly you could use, right? So when I tabulate my region variable, I see now just West, but you guys probably see more than West, and you see West and some other thing. Okay, a couple of other things you might want to do to manipulate your variables. One is rename the variable. So if you wanted to rename this variable that you created from region to census region, all you would do is say rename region census region. And now you can see here that it changed up in the variable window. If you say describe census region, it's there, right? So very simple command. You might want to label the variable. So these things right now don't really give us very much, but if you want to put a plain English language label on it, you could say label census region and then say region of the country or region of the US, something like that. Sorry, label variable, apologies, label variable, census region of the US. It's getting close to 9 o'clock, I'm starting to fall asleep at the wheel here, guys. All right, so label variable census region of the US. And we can see here the label changed. And if I describe census region, I get region of the US. Okay, under the variable label. That's just helpful for knowing what's what if you want a description. Okay, there's one other thing that we might want to do is that, so to give you an example, if I tabulate sector, one of the most important things in higher education, knowing basically is a school a public school, a private school, or a private nonprofit school, turns out to be something that people are very interested in higher education. And that's known as the sector often. And it turns out we've got this sector variable in here, but it's just looks like this. It's got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and also 99. And the question is, what does any of this mean, right? I know that there's 1,687 schools with a sector of 2, but I don't really know what that means. So what am I going to do? Well, it turns out that we have to go to the documentation, and the documentation can tell us what that means. But we might want to have it in our data so we don't have to keep going back and forth. So here, if you look at sector, and it gives you the value. So sector, if the value is 0, it's an administrative unit. If it's 1, it's a public 4-year. If it's 2, it's a private nonprofit 4-year and above. Okay, so there's a bunch of these different values. And what we want to do is we want to keep these as numbers because Stata, it uses less storage if they're numbers, but Stata gives you the ability to add labels to these numbers. And so I want to show you how to do that. So what we did just before was we labeled the variable. We said label variable census region, I'm sorry, region of the country. So that gives the variable a label, but we might want to give the value. This is called labeling values. So if we say label values, census region, the thing we're going to want, the label we're going to want to add is going to be some set of labels that we learned from the documentation. But we don't have that set of labels coded up yet in our data. We just saw it in the documentation. So before we can label the values, we have to establish the label scheme. So what we're going to do is we're going to say label define. And we can define our label. We have to give it a name. So the label scheme, we're going to call it, let's call it region label. I often do something like that. And what we're going to do is we're going to tell it what values pertain to what thing. So we'll say 0 pertains to a, in quotes, admin unit that we remember. 1 pertains to a public 4-year. 2 pertains to a private not-for-profit 4-year. 3 pertains to a private for-profit 4-year. I'm going to go down to the next line. 4 pertains to a public 2-year, and so on. And so this will give us some sense of it. And so now I've got, if I run this, I've got my label defined. Nothing has changed about my data, but Stata now knows that if I want to add this region label to any variable that I choose, for that variable, when it sees a 0, it will give it the label admin. When it sees a 1, it'll give it a label public for you. When it sees a 2, it'll give it a label public non-for-profit for you, right? Okay, so now I go back to my original label values command, and I say label values, okay, the variable that I'm going to label is census region, and the value that I'm going to, or the value labels that I'm going to add to it are region label. That's the value label scheme that I set up here. Okay, so if I do this, may not label strings. Oh, I'm sorry, not census region. I'm labeling the wrong thing. So this should be called sector label. I apologize, sector label. And we're going to label the sector variable sector label. Okay, so it's good to normalize error here, guys. I make mistakes too, even at my advanced Stata age of whatever my Stata age is. And so it happens all the time. Don't take it as a personal failing. And so, okay, so label values, sector label. So I've established this label scheme called sector label. I've got a variable called sector. I'm going to add the sector label to it. I can run both of these, and then I get this tab sector, and I'm going to see a couple of things. So the ones I labeled now have labels on top of them. Okay, the values have not changed, but they have labels on top of them. These ones that we didn't label yet don't have values on top of them. So I'm not, I'm not too worried about that. But to show you that this is true, I want to give you a chance to install another user-written command. So let's install this user-written command called FRE. So we're going to say ssc install FRE. And luckily, this one works no problem. It should install for you no problem. And then once you have FRE works just like tabulate tab. If we type FRE sector, what's really nice about FRE, the reason I use it a lot, is that it shows you both the label and the value at the same time. So what this can do is prove to you that these values are still here. And if you were going to do an if statement, you would have to reference these values, not these words. But if you were going to do an if statement, you do this. So these values are here. We just haven't finished labeling the rest of them. So you could fill out the rest of your labels if you wanted to by filling them out. For time, I'm not going to make you watch me fill out all these labels, but we're often running with adding labels. A moderate amount of time, I like to add labels to my data just to make things more readable, especially if you think other people are going to read your data or use your data, and it's not clear what the value labels are or what the values are signify. It's a really good idea to add value labels. Okay, so let's add. I'm trying to decide here. Why don't I call a vote here? Let me just stop sharing real quick. We can stop here and pick up and do merging. I mean, everything that's on that document that we haven't done yet. Merging loops, merging, appending, loops, graphing, and statistical testing in the next class. Or we can trudge on through. And I can do basically appending and merging tonight and leave a little bit less for next time. So why don't folks who want to do tomorrow night, or sorry, not tomorrow night, next class, give a thumbs up, and the folks who want to keep trudging on tonight, do like the clap hands thing. I think you can do those different reactions. And I think I can see everybody, so if we get the votes. Okay, so I think that thumbs up won, but here's what I'm glad to do. So for those of you, if you would prefer to stick around, what I will do is I'll start the next class with this material, with the merging and appending. But if those of you who want it, if there are people who are worried about not being able to come next time or whatever, although I am recording these and so folks can always get them online, I'm glad to stick around and show you how to do merging and appending. So one last thing, Bradley, I'm glad to do a Q&A time now. That would be totally cool for me. And folks are glad to stick around for a Q&A time. Let me just before we shift to that and before folks start to depart, let me show you really quickly probably the most important Stata resource on the web, which is Google is the most important Stata resource on the web, just like Googling your errors and Googling how do I do whatever. But short of that, there's this thing called Stata cheat sheets. They're totally free. They're on the web. I print them out and laminate them and have them at my desk when I, in the former world where we used to work at desks. And they're really nice because they have a nice overview of lots of different commands, how they work, what they do. They're put into these nice different categories. So like a lot of the stuff that we've done, right? Set up PWD, CD, DIR, right? All these things. A lot of what we've done is here. A lot of stuff we haven't done, but that is still useful is here. So you could look through these and be, I think one of the hardest things when you're first learning is remembering what the command is and how it works and what it does. And so, having that to spark your brain is really nice. And so there's a lot of stuff that we went over here, especially in this data transformation and data processing things. But they also have a great thing on graphing, and they really have 2 pages on graphing, and they have a bunch on programming and loops and merges and reshapes and all that sort of stuff. So so great. Hope you guys had fun. I'll stick around for Q&A. Otherwise, I will send out a thing and try to make it so that folks can make it. We'll get a survey out and try to figure out what is the time it'll work for people to finish up things. Sorry, it didn't all fit into tonight, but trying to cover a lot of ground. Hope this has been helpful. And hopefully I'll see you again next time. All right, stick around if you want to do Q&A.
Thanks, CJ. So I appreciate how at the beginning you sort of framed this with, most of us are used to having our Excel spreadsheet open.
Yes.
And we can see the data, we can manipulate, we can copy paste, we can filter, we can sort. And totally. That's what I really hate about Stata is that you can't really do those things.
You're working blind.
I know that we used sort earlier. I've been learning about the order command when I just want a column in a different place.
Yep.
What about if I am just browsing my data and I just want to filter and say, I just want to see Michigan colleges, or I just want to see public colleges, how do I just browse my data like I would as much as I can, like I would in a spreadsheet?
Yeah, so why don't we just look at the private for-profit 4-year schools? So if we were to say, I could say browse if sector equals 3 here, right? And what that's going to show me is just the for-profit schools, right? And to really prove that to you, I could say browse if I can specify which variables. Often you don't want to see the whole data set, so you would want to just say, let's say browse inst name and city and sector or something like that, right? And so this will show me the sectors, and I can see that I've got all the private for-profit 4 years, South University, Charter College, right? All those. And so this is only those. Is that what you're looking for?
I think so. Show me that code again.
Yeah, of course. Yeah. So all, just like we were using the if statements before, we're using the if statement here to condition on some variable, right? So this is essentially what you're filtering on, right? You're saying, I want the sector to be equal to some value. So I'm going to say if sector equals 3. So you can just say browse if sector equals 3, and that'll show you the whole spreadsheet for those folks. Or if you want to just see certain variables for those specific things. So here I just chose the name, the city, and the sector. And I put that same condition at the end. Did that work for you?
Yeah, that's helpful. Thank you.
Yeah, no worries. Other questions?
DJ, great.
Yeah. Sorry, go ahead.
Just want to thank you for this. This has been really informative. I have a question about cleaning data.
Sure.
I know the data sets that we've been working with today are fairly clean,
Totally.
but I'm thinking about a data set that I've accessed that includes information about workforce training programs, including those that are offered by community colleges and proprietary vocational schools. And I'm particularly interested in looking at program outcomes based on the length of the program, but there are probably like 50 to 75 different ways that the length has been represented. Like,
got it.
1 week where 1 is a number, 1 week where 1 is spelled out, spaces in between,
Totally.
ranges. And so I guess I'm just wondering, like, how would you go about first cleaning the data so that it's at a place where you can even do some of the work that we've done today?
Yeah, so it's tricky, and one of the things that's challenging about it is that it's so idiosyncratic. So it how exactly you clean depends on what exactly you see. I have a few thoughts. So I think probably our messiest variable here would be something like the addresses. Or the names and the addresses. So let me just get these together. City, Stabber, zip. Okay, so if I'm browsing this, like, things that could get tricky here are like this and symbol, right? Or sometimes the spacing is weird, or like JF Drake here, JF has a period after it, and here it doesn't. Here, yeah, like I said, here it doesn't, but there's spaces in between, and yada yada yada. So there's a bunch of different things. There's a few like go-to commands that I use a lot. So one that's really nice is I could do something like replace inst name equals strupper string upper. You might be able to guess that this is going to give you the uppercase version of all these names. One of the things to me that I find most often, especially with addresses, is that they, like, is MCC M lowercase c uppercase c, or is it M lowercase c, or is it M uppercase c uppercase c? Like there's all these case situations that make life sort of hectic. And so if you just make everything uppercase and then browse, I'll browse the same things. You can see that now they're all uppercase, right? You could of course also make them all lowercase if you just preferred that. And the command for that is string lower. And then let me think here. What else? So there's also string proper. So replace inst name equals strproper. So that's for like proper nouns where we're gonna capitalize every separate word. So I should spell things right. And so if I browse this, I can now see these are back to sort of what they were, where each word is capitalized. This probably wasn't what it was exactly because at probably wasn't capitalized before, so you have to be careful with stuff like that. But generally, like for me, I like to uppercase everything if I need to like standardize it. That's one thing I need to do. So there's a couple other things you can do. So sometimes there's extra spaces and stuff. So if you say replace inst name equals strtrim, string trim, strtrim, inst name, what you get is, this doesn't have any extra spaces, but if you had something that had extra spaces in it, that would remove the spaces. Sometimes, like, especially if you have people who did manual data entry, you'll have some extra spaces at the beginning or at the end. And so this will take any extra spaces at any point. So it'll assume that 2 spaces is wrong and reduce that to 1 space. So string trim is a really useful tool. I'm trying to think what else. So if you wanted to just replace, yeah, this will be a very useful one for you. If you wanted to just replace an instance of a letter, so like you have something like 1 week, right? But I don't have that in my data, so I'll just try to give you something similar. So if I said, I might have in this data, the names might sometimes have university and might sometimes have univ, right? So one thing I might want to do is say replace inst name equals sub in string, so subinstr, and then I specify the variable that I want to change, so inst name, and then I give it what I want to look for. So if I want to look for university, and then I want to look for, and so I tell it what I want to look for. I want it to find university. What I want to replace it with is univ, and then I want to do that for all of the instances. So I put period, right? So so if I say replace that, it makes all these changes. And now if I browse inst name, I can see that wherever I had university before, now I have univ, and it's it should catch it in the middle. If you wanted to change community college, you could to COMM, you could do the same thing. Let me just show you quickly how to get help on these sorts of functions like this that are a little tricky. You say help sub in string and then parentheses, open parentheses, close parentheses, and it tells you how it works, right? And so it says sub in string S1, S2, S3, and N. And so S1 is where the first N occurrences in S1 of S2 have been replaced with S3. So in S1, we want to find S2 and replace it with S3. And then the N is the number of occurrences we want to replace. So this is a great example here. It says, we've got this string, this is the day. We want to replace is with X, and we want to do it just for the first appearance, right? So, this is the day is appears here and here, but it only replaces the first one and not the second one. But if I do 2, it replaces both. And if I do dot, it replaces everything, right? So this is the this, or this is what they did here, and it replaces it in each place. So I always do the dot because I basically never find a situation where I only want to replace just the first version. So if you had something like replace program length, imagine you had a variable called program length and you had sub in string program length, and some people were writing it as 1 week, and you wanted it to be replaced with 1 week, or like 1 week or something like that, right? However you wanted to standardize it, and then a comma and a period, and it'll replace every instance of that for you. Let me think here. So another thing that you might be interested in is the substring. So a substring will allow you to extract a smaller part, starting at a certain character and ending at a certain character. So if I say help substring, I can see some examples. So if I take the substring of A, B, C, D, E, F, and I start at character 2 and go for 3 characters, what I get is B, C, D back, right? And so, similarly, if I start at -3, I'm starting from 3 from the right and going for 2 characters, what I get back is DE. If I start at 2 and go to dot, that means I go from 2 to the end. If I start at -3 and go to dot, I go from 3 from the right to the end, and that's what it gives you. So you can see what that does. And so if I wanted to say just get the first 5 letters of the institution name here, I could say replace inst name equals substring inst name sorry 1 5, right? So this is going to start at character 1 and go to character 5. And I can now browse inst name and I can see that. Okay, and here's actually a great example of where like the first 5 characters includes a space. And so let me show you how string trim will help with that. So if I say replace inst name equals strtrim inst name. So now I'm replacing with a trimmed version of inst name. It makes a bunch of these changes, and now when I browse inst name, that extra space at the end is gone. Let me show you one last one. This is a little bit more advanced, and you're going to need to install some stuff. So, so if you type ssc install egenmore, and then also ssc install ereplace. It may take a second for this to go. Okay, so I guess I already have ereplace, but you would need to install ereplace as well. And so replace has this nice, ereplace is a sort of extended replace. We've done replace before, and egen is just an extended generate. So they're complementary tools. But if you look at help egenmore, it's got this nice thing called sieve. So what sieve does is it selects characters from a string variable according to specified criterion and generates a new string variable containing only those characters. It can also omit characters. This may be done in 3 ways. First, characters are classified using the keywords alphabetic, any of the alphabetic stuff, numeric, or space or other. So keep tells you to keep from these classes. So basically what sieve does is just like its name implies, it's like a sieve. It filters out things that you don't want. So a big thing that might be a problem is like we were saying with the institution names. Actually, I'll do this with addresses now because I've sufficiently hacked down the institution names at this point. So this has got a bunch of different stuff in it, right? So it's got letters and numbers, and it may even have some periods and things in places, right? It's got periods here. And so I may want to get rid of all that stuff. And so what I would do here is I could say replace, and the thing I want to replace is address. Let's see if I can remember this off the top of my head. So I'm going to say sieve, and then what I'm going to do, I'm going to have to look at this again. Oh no, I'm going to say sieve address, and then I have to tell it which things I want to keep. So I think I want to say keep alpha, so alphabet stuff, numeric, and spaces. And so if I do that, what it does is it gets rid of anything that's not an alpha or a numeric or a space. And so if I browse the address now, before where I saw, let me see if I can find that SE place. I think US Highway probably had periods in it or something. Before where I had all these weird characters, it's hard to find a good example, but you can see, where was that? I'm not sure, but you trust me that, and trust Stata when it says here that 1429 changes were made. If you have funky characters, this sieve thing will give you some help with getting rid of those funky characters. And again, if you look at the help for egenmore, you can just look at the sieve file or the sieve area, and it'll tell you exactly how this works and how to specify these things. So I would suggest to go with that. Hopefully that's helpful.
Incredibly. Thank you so much.
No problem.
So right there, sorry, just jumping in, right where it says, 1429 real changes were made, is there a way just to view
the ones that were changed?
Yeah.
Yeah. So there is, but it's a little bit of a hacky way of doing it, by which I just mean like it doesn't come naturally, but you can. There's a way that you can do that. So so what I'm going to do is I'm going to say I'm just going to make a copy of my address variable. So I'm going to say gen address copy equals address. Okay. And so now these two should be identical. If I browse anything starting with address, I have address and address copy, and they're exactly identical. It's hard to see them at the same time, but they are, I promise, exactly identical. And so now if I just change one of them and I keep the original copy, or I keep the copy untouched, if I did something like e replace address, sorry, hold on one second. E replace address, and I, for some reason, wanted to get rid of the numbers. Actually, no, that'll get rid of everything. If I get rid of the spaces, I guess most of them probably will have spaces as well, but in any case, so if I get rid of the spaces, it generates 11 missing values. It made these changes, and then what I would do is I would say something like browse if address copy does not equal address. So the exclamation point, sometimes called the bang, bang plus equals means not equal, and so it's going to tell me, it's going to show me just the observations where these things were not equal. I should just do, so I'm going to browse address and address copy, and it'll show me where the ones, where things weren't different. So this is what it was originally. This is what it looks like now, and it got rid of all the spaces. Any other questions, guys? I'm not intimidated by the 9 o'clock time. I'm glad to stick around. So if you have questions, don't hesitate. Okay, I'm sure everyone wants to go to bed or watch TV or something. So thank you guys. I appreciate you sticking around, and hope this was helpful, and hope to see you next week sometime. Okay, I'll talk to you guys soon.